Okay, so today, so first of all, let me talk about Wednesday. Remember, you're going to do Chapter 9, Bullet Bandit. So that's due before the start of class. We'll probably spend the whole class talking about Chapter 9, is my thought. If you guys talk enough. Yeah, from the urban. So it's Bullet Bandit, but it's from our textbook, Chapter 9. Because it's really talking about different societies and different things. So Chapter 9 in here, yes, not in.
And every subheading too.
Yeah. Yeah, same thing. Let me see it. Yeah, they just got similar type of little subheadings on little pages. So.
Is there anything due on Friday?
There is now. No. No, not Friday.
Yeah. So we got.
I'm gonna start in on Chapter 10 right now. We'll probably work some problems on Friday. We'll see where we get today with stuff, but
I won't be here Friday.
That's our plan. Got it.
I'm gonna email you.
Okay.
Yeah, we have a bowling tournament.
Bowling for dollars. That was a TV show or something, I think, years ago. Have you ever heard of that?
No, I haven't. I want to look that up now, though.
Yeah, don't do it now.
No, I said I will.
Okay, so what we're going to do is start on Chapter 10. So I figured I'd give you guys the weekend off since you worked so hard for your test on Friday.
Appreciate it.
We'll start on Chapter 10. So we're going to look at how prices are derived, I guess, in real estate, between rent and maybe egg prices. And ultimately, Chapter 11 will get into office buildings and different things. So that's kind of the idea of it. So land rent. What is the price of land and where does it come from? What do you think? Where do we get land? Do you guys know any land prices? Like, I can't remember, do I have some farmers in here? Or roughly that you got some connections to ag or something? So what do you guys know what the price of ground sells for?
It's different in different states.
It is different, no, that's what I mean. Whatever your state is, what give me a ballpark of?
In Iowa, it's pretty high right now.
Yep, it's pretty familiar.
It's extremely cheap where I live. It always is.
Where's
Lubbock, Texas.
Oh, Lubbock, yeah, their ground is close to Robles.
All you can grow is cotton. There's no rain. Yeah.
So, yeah, now you just kind of said it, Daniel, say that again. Why is it worthless?
There's no rain, and so all you can grow is literally cotton.
No rain, so you're basically a desert.
It is a desert climate, yeah.
It's very sandy.
Desert,
right?
yeah. Yeah, my house is literally in the middle of a cotton field.
Yeah, so cotton is the crop that's good
They
for
used to be able to grow wheat back like my dad when I was really young grew wheat, but then the wheat crop just died out. Like we're not able to grow it there anymore.
You got just a rough ballpark of what you think land goes for? Look at that.
I don't know though.
Your first instinct there is like to go to your keyboard.
I want to. I just want to know.
Resist the keyboard. I can probably tell you. I mean, I can speculate.
Iowa, like 7,000 to 8,000.
Yeah, it's probably around 7 to 8 in Iowa. So in Iowa, what are we growing?
Corn, soybean.
So we got rain and black rich soil. And we're growing what? Corn and soybeans. That's all the examples I had in econ when I taught at Iowa State University. It was a continual rotation of corn and soybeans. Corn and soybeans. Other farmers going to do it. So you got crop rotation, all the stuff like that. So I think Grady's probably about right now. Let's just say the 7,000 per acre for farm ground. And for farm ground in Lubbock, I would guess 2. We can do afterwards. Daniel can search for it and see if we can get some better numbers for
Based on
Wednesday's class.
If I had to guess.
Yeah, and some of it, like even in Missouri, and they can go 1,500 depending on. I mean,
yeah.
They can be pretty cheap depending on location, of course. So that's what I want to talk about. So what's driving these prices? it's an acre of land. Like if you wanted to build a house, you've got an acre of land to work with, but yet it's 2,000 up here, 7,000 down here. What you can do, okay, so what kind of doing are you talking about? Okay, so farming. So let's restrict ourselves to farming for starters, and then I'll kind of bring you down a different path. But so let's say it's farm ground right now. It's zoned for farm ground. There's not really any cities nearby. You're kind of in a rural area. Okay. So now where did the prices come from?
The profitability of what that you're able to grow.
Yeah. So that's going to drive it, right? So what are soybeans and corn selling for? What is cotton selling for, right? And then so what else would go into that? Think about, I've got 1 acre of land. Let's just normalize it to 1 acre. How much you can grow, right? So how productive is the land? So in Iowa, you put some seeds down on an acre, you're going to get a certain amount of crop, right? And you do the same thing in Missouri on that acre of land, and you're going to get less production per acre. So sometimes it's not what you can produce, because both ground might be good for corn. Like you can do corn in Missouri, you can do corn in Iowa, but because of the nature of the soil and maybe the climate and rain and other things, sunshine, whatever, all that balance of stuff you need, if the Iowa ground's more productive, if I get 50% more bushels of corn out of an acre, then it's more valuable, right? So I can put down the same amount of seeds and it be more productive. So the profitability of the land in terms of the farming sense is what's going to completely drive the amounts of either rent or the price per acre. So these are prices per acre. So you go to buy 100 acres, and is that a significant difference? So you've got a 100-acre plot. Yeah, a couple 100,000 versus 700,000, right? So that's a significant difference here. Almost 4 times the amount that you're paying for. Well, why? This ground's probably 4 times more productive. You know, if you had that in terms of like corn to corn instead of cotton to corn, then it probably would be directly related to productivity. Because the amount of farming, the equipment that you're using, the fertilizer that you're using, all of that's the same, right? It's all going to boil down to how productive is that soil? How many bushels per acre can you crank out? Because the rest of the variable costs are probably similar in both states.
So in a state that's like not super big, like Iowa, then like from the west side to the east side, what do you think like the price differentiation is going to be between like an acre?
They're pretty similar in Iowa. There's not a lot of variability because that rich black soil spills into Illinois and into Nebraska, and I mean it's that kind of that whole region. So Iowa just happens to be kind of jam-packed with fertile soil all over the state. Okay, so that gives us a little inkling of where value comes from. So market value, when we use that word, we're thinking about the purchase price. If you're going to go buy some land, what is that going to look like? And land rent, on the other hand, would be an annual amount. So a lot of farmers do rent their land. It could be I think this class we saw a video, some person as part of their overall wealth portfolio, they could have a lot in mutual funds and they could have some stuff invested in India, and then they own some land. And they have no business being a farmer, but they just purely have it as an investment because they know they can charge X amount of rent. And so they want to hold on to some land for rent. What's the thing that could change the market value of our farm ground besides farming? Jobs? For the farming example, that's probably going to be less of an impact.
Like for reason, the raiders are coming in, the increase in value, market value.
Okay, I mean, if that's where you're going with it, but I'm thinking about the land value. So where is that land relative to other farmland, if there is such a thing in Las Vegas, where the raiders are playing versus the one 100 miles away? which one's more valuable, first of all? The one where the Raiders are playing or the one 100 miles away? Where the Raiders are playing. That land is more valuable. Why?
The stadium open.
Because the stadium built on it. What about the land kind of a mile from the stadium?
The trucks.
How is that relative to the land 100 miles from the stadium? More expensive. Why?
The stadium is nearby.
Nearby, right next to the city. And so what could happen to that land in the next 10 years? Turn into a housing development, right? So now we get into the speculative nature, which I think it sounded like after you were describing your job thing, maybe that's where you were going, is that as the city starts to expand, then you might be able to get your land rezoned to allow for housing or stadiums or manufacturing or offices or whatever. So that gets more into the land speculation business. So if you have land that's just, very rural, probably not a city nearby for maybe at least 200 years or something, like, nobody can go 200 years out, but at least in the near 50-year window or 100-year window, like there's no way in hell a city's going to develop, right? You guys know plenty of land like that. Well, then it all comes down to this, where what is the amount for the rent? Now, as soon as a piece of land, even 30 years out, it's like, this was part of my business with land development, the guy that I ended up getting involved with, partnering in the fun stuff. He was a land speculator, so he made a lot of his money in insurance, but then he'd see a piece of land, farm ground that was like way out of town, and it's like, why would you pay that kind of money for farm ground that normally would be $7,000, he paid 10. And so some of his friends might be saying, what the hell are you doing paying 10,000 an acre? Because a lot of times this stuff will go up at auction. And so he'd be the highest bidder, to bid up to 10,000. And because he thought that that's where the city was going to move to eventually, and he was in it for the long haul. Now, people got wrong on that too, that the city doesn't move that way, it moves this way, and then you just way overpaid, right? So that's a lot more speculative in nature when you start trying to predict where the city's going to move to. There's a lot of moving parts there. So it gets a lot more riskier, but the returns can be pretty nice. So just to go back to that story, some of the ground that he bought for 10,000, 10 years later, some of it sold for 200,000. So bought it for 10,000, sold it for 200,000. So the stuff that was able to put apartment building. But nobody could have, it's pretty difficult at the time he did it. He took on a lot of risk, but he got a lot of reward for it too. Okay, I helped with that development, but I was not an owner at all on that. But that's when it kind of opened my eyes. This land speculation stuff, that sounds kind of fun. Okay, so is everybody okay on the land rent? So, I mean, it's like renting your apartment essentially, right? You just have the right to use the land for a period of time. You might have to do some things to the land. Perhaps the landowner might have some improvements that you need to do as part of the lease, but you just have a lease like you do for an apartment lease. Okay, so give this a read for the leftover principle. So, zero economic profit. What's that again?
That's the long run.
Long run, that's a prediction of the competitive market in the long run. So that means you're making no money?
No.
No, it means what? Takes into account opportunity cost. So it's okay to earn zero economic profit in economics class. You're still earning what kind of profit? What do we call that?
Accounting profit.
Accounting profit or a normal profit? Well, the reason you'd use accounting profit could be a win or a loss or whatever. It's just going to be less than the economic profit. But the profit equal to zero means you're earning a normal profit. That is different than an accounting profit. So we got profit equals what? Total revenue minus total cost. And so opportunity cost are included in that. And so when this thing equals 0, we're still earning a normal profit. Not a super high profit, not a super low profit, but a profit that does what? If it's normal, what does it mean for competitors or other firms thinking about entering or exiting? When you're earning a normal profit, is there incentive to jump in? Yeah? No? No. So that's the trigger, is that you're indifferent anyway between entering that market, because there might be, you're always looking for the highest, most profitable thing. In this case, if it's just a normal profit, it's like, I don't have incentive to go in. I don't have incentive to leave, by the way, either, the firms that are in there. So what do we call that if no party has incentive to make a Nash equilibrium? So the Nash equilibrium in a competitive market, in the long run, is firms earning a normal profit. No firm has, holding all the things constant, any incentive to make a unilateral deviation, as this textbook says. Okay, any other questions on that slide there? Okay, so I guess give this a read first. Okay, so let's do an example. So write this down in your notes. This would be an example. Suppose Iowa farm ground generates economic profit of say $1,000 per year. How much is the land worth today? Okay, don't use this formula. This formula is kind of wrong. I'll use a strong word. It's not really wrong, but there's a reason it looks the way it looks. So I want you to put on your thinking caps on a question like this. You have the opportunity to buy some land. At this point, it's $1,000 per year. I want you to set up an equation on your paper. I'm not looking for a number. I want an equation that shows how much this ground is worth today. Set up an equation to show how much this land is worth today.
See this one? 1 unit.
You answer, you make the assumptions you needed to, and show me an equation I'll give you a hint. Think about present value, future value. Looks like present value problem. Anytime you see Iowa farm ground generates economic profit of $1,000 per year, what's it worth today? All right, looks like, yep, you're on the right track there anyway, for starters. Nate needs a nudge. I see a big blank page here. So start with PV equals.
That's what I got.
Okay. So that's one of your Lynn Wagner tables. See, that's why her and I disagree on that. So I want the formula behind that number.
I was going to do the same thing, but then I thought
How much is the landlord?
So it's
That
not,
looks
but
like
it's
some sort of,
his version.
that's a counting formula too. Ooh, Liz, let's see.
I saw it.
Oh, okay. So let's see, where else did you guys? You got the PV equals, where's your formula? Oh, okay, yeah. Okay, you're on the right track there. Is this the present value formula? Yeah, it'd be the present value formula. That's it? Okay. All problems like this are the present value formula.
So it's the payment times 1 plus the rate to the power of n minus 1 divided by rate times 1 plus the rate.
So let's we haven't done this in this class here. So you got $100 and you're going to invest it at 10%. How much do you have next year on a simple just annual compound? 110. Some of you have seen this. Some of you would have the right answer down, probably remember this more than others. Every one of you should have this memorized before you leave out of university. Equals
110.
110. Let it ride another year. What do we got?
121.
121.
Compound interest rate.
Oops, 121. Need that dollar, that's for sure. That's compound interest, right? So now this sucker equals this sucker, and this sucker is this sucker, which is equal to this sucker. So let's put that sucker into that sucker. What can I do to this expression to simplify it? Square it. So present value equals 1 plus the interest rate raised to the n power equals the future value. Just like that. You were missing your exponent, I think, weren't you? Or were you just doing the one? That was your first one. So with this one, we've got 2, so it's squared, so we're going out 2 times. So the present value equals the future value divided by 1 plus I raised to the number of time periods. So this is the fundamental equation of finance. That is the most important one, I think, in my opinion. So now do it. Set up the equation. We don't have I,
Yeah,
so make an assumption for I. Use the equation, but I want to say, what should I be? I equals what? Not a number. I equals what? Lay out the equation first with the I's and everything. I'm going to come around and make sure you guys got this laid out right. You're not done yet. This is $1,000 per year. So start writing it out. I will correct you if you are off. I will nudge you. I want to see you guys put it down on paper. Okay, so do that. Future value is what? According to that problem, suppose you found some higher farm ground generates economic profit of $1,000 every year, like clockwork. So what's the future value in that problem? It's 1,000, yep. So go ahead and write that out.
What is the number of years?
Ah!
So they're
Yeah, make an assumption. So what is I and what is N is kind of 2 things you guys need to grapple with. What is I and what is N? And you got to show the proper format for the equation,
I think, yeah, anything would be 1. Yeah,
So just put an I in there,
that makes sense.
and then raise to what power? Nope. That would be for a bunch of periods, N. But how many, like what's the first year? What would be the exponent for 1 year? 1. Yeah. But then are we going to hold it longer than a year?
Maybe.
Not maybe.
Yeah.
According according to this equation, the way it's set up, do we have a second year that we need to factor? We're holding it. I don't know when I'm going to sell this farm ground. I'm just trying to decide how valuable it is. So I'm going to have this out for 1,000 years, maybe. That would be enough. Maybe I'm going to hold it 1,200 years. I'm going to pass them along to generation after generation. 1,200 years. There's some European ground that's been passed along at least 1,200 years. So get the first year. Everybody should have the first year on their paper. Okay, but now you need it to the 1 power, right? So put it to the 1 power. And then do the second year. And then do the third year. And then do the 4th year. And then do the 5th year. And then do the 37th year. And the 38th, don't forget. And the 52nd. So that's good. 1 plus I. Go ahead and make the I generic. And now put plus the second year. And the 3rd year. And the 4th. And the 37th. And the 48th. Okay. You must. I don't want any numbers at this point, so just leave that I. Show me the equation of what you're actually doing. Yeah. Let me see. Nate actually maybe had it figured out. So, Nate, come on up and show your work.
Come on, that's right. Oh,
Finally, we have somebody, and he's showing the glimmer of hope.
Future classmates. How's it going?
He's graduating, so that makes me feel warm and fuzzy when I have our graduating senior. So many years and so many classes, so many hours. Okay. Now, put the last one on there too. Well, I guess not the last one.
It's like the.
Yeah. There you go.
Yeah, that's nice.
Yeah. Okay. Grab seat. Good job. Okay. So this goes on for n. I said it was n equals 1,200 years. So that'd be a lot of writing, right? How long would we have to wait here to see that, to fill up that? That would be kind of cool. Maybe we'll do that. Have somebody come in and just take a picture. This, our professor gave us a problem of what's the present value. Okay, so that is our present value formula, going out n time periods. And so now, can't we simplify this or something? Can we solve for I or something like that? Turns out we can't. So you can't like break this down. This is the raw equation. This is it. You can't like combine terms or anything like because of the square term. Long story short, it's one of those math rules. All right. So what is I?
The interest rate.
The interest rate. A little more to that. What's that on?
Market interest rate.
Market interest rate. Getting closer.
The face rate.
The what? No, not base. Nothing to do with bonds.
Does it have to do with some of the payments?
No, if there was, I mean, it could be in different contexts, but not in this context. So I'm a speculator. I'm Ev Cochran. That was the name of my mentor, multi-millionaire boss here. And I'm thinking about this. What is I? Oh, the senior gets it again. What is it?
Opportunity cost.
Opportunity cost. What else could you be doing with your money today? Well, I could be investing in this other deal that my brother's doing, and it's got a 30% rate of return. So when you do the discounting, if your opportunity cost is 30%, you shove in a 30 there, right? Now on the flip side, it's like, well, my money's earning 5% rate of return in this little account. They're investing in some other stuff, and I wouldn't want to do anything more with that money. Then 5% is your opportunity cost. So 10%, it's totally a custom answer. This is really when you get into wealth consulting. that I would depend on who you're dealing with. What is their opportunity cost? If it's dear old grandma who's needing to just keep stuff, fairly liquid or something, it might be lower. If it's somebody else, it might be higher. So a lot of times an investment like this, what's our expected long-term average in equities in the stock market? 10%, yeah, 8 to 12. I mean, you could, again, pick a number between 8 and 12, but that's a lot of times people's opportunity costs are like, oh, should I invest in land or should I just keep it in the stock market? If you perceive that land is more risky for some reason, depending on what you're investing in, and you can get 8 to 12 in the stock market, maybe you mentally think, I better get at least 16 or something out of the land. If, on the other hand, you perceive that land is safer than the stock market, which, by the way, it very well could be. A lot of times land can be really stable, especially in good areas that's productive land. Then the rate of return might be less than what you get in the stock market. So that's getting into kind of the risk-reward trade-off. So even if there are differential rates, that would be equalizing for risk. All right, so I is your opportunity cost. So what is I? Depends on opportunity cost. So what is N? That is going to be, if we're holding it indefinitely, then in this case, we kind of want to think about it being infinity. We don't know if we're going to sell it or not. Of course, on a different problem, I'm going to buy Iowa farmland so that I can put my son in college when he's 18. So we've somehow defined the N to be 18 years because he's a baby now and I'm going to put him in college when he's 18. So then you might do the problem differently if it was situated like that. But otherwise, we're kind of thinking about this running off to infinity. All right, so let's have a little Excel fun today, I think.
Hey, actually.
So you guys should be familiar with doing some present values in class or in this way. So if we have $1,000 and we're going to do that, let's go 30 years for starters. And then this equals the present value of this. Oops, that's not this. In fact, let me just do the rate here. So let's do some stuff over here. So we've got, let's just do a 10% interest rate, 0.1 interest rate, and we got the 30 years. Well, actually, that's going to depend on, I wasn't going to get this detailed, but what about it? Let's actually do the equation. You guys have faith that I'm not just pulling the rug over your eyes. Equals 1,000 divided by 1 plus the interest rate. F4 is the quick one with dollar sign, because I'm not going to fill that one down, raised to this power. And somebody did 909, JC did 909. So that is the first discounted sum, $909. What do you think the 30th year is going to bring in? 3,000? No, is it going to go up or down?
Up.
The present, hold on. What's going to go up? We have $1,000 per year. So is the present value of the 1,000 going to go up or down? Is $1,000 3 years? Which one's more valuable? $1,000 3 years from now, or $1,000 next year? Next year. $1,000. Remember, we're getting $1,000 in the future.
I was thinking the other.
Yeah. If your brain gets the other way, you got to come back. So we're wanting to bring this $1,000 back to present day. And so after 30 years. Oops, that didn't work out so hot.
Yeah, you jump into the formula.
Oh, I didn't do it. Oh, you guys know how to do an exponent?
Carrot top.
Yeah, little carrot top. Where's my carrot top? Shit, I haven't done that for a long time.
6.
There she is. Okay, 6 to the 1 power. Now I think I'm going to actually have to close this off. Okay, now
That's
she
only
gets 57 bucks. So if we go further, we get to eventually it's just adding a fraction of a penny, right? So even with it, what?
Here that is, I'm gonna drag down.
Sure.
I was scared.
Let's see. I think can I break down the whole thing? I can. No, not this one. $129. There we go. These I can break. Okay, so here we're at a penny, $1,000 in 117 years from now, right? How long is the normal mortgage?
30 years.
30-year mortgage. One of the reasons is because money becomes kind of worthless after about 30 years. So check it out. Here's year 66. $1,000, 66 years from now is $1.85. Okay? So that needs to go on for infinity, though. If you're going to really solve the equation, you'd keep going to 1,200 like I wanted to. And then if you point 0, you know, you're basically adding next to nothing once we get down to that point.
Is inflation rate on average 10%?
What?
Inflation rate on average 10%?
No. This is not fair. It's with factor in inflation, you should subtract it off. If you thought inflation was going to be 2%, then it'd be 10 minus 2%. If you wanted to have a real rate of return. Okay, what was I going to do? Oh, let's add these up. 129 years equals, let's see, it should just do this quick. Awesome. There it is. $999.95. That's the sum of all of these. So this equation, going out 66 times, doing that same thing by hand, those are your numbers. And if you add them all up, how much is the land worth? 9,999. We round up, we can call that maybe 10 grand. So 10 grand investment. Now, back to the textbook. Do that. Go ahead to your calculators and do that. The interest rate, 10%. R is the amount you're going to get, the land rent of $1,000. So you're going to get $1,000 of land rent divided by 0.1 equals. So this is a mathematical. It's an expression that it's a simplifying thing that this equation, you can do a whole bunch of math and mental masturbation to get it to work out, but you can show that that ugly thing that goes out 1,200 times, a mathematician came up with that. I can't really give credit for that, but came up with that expression. So it's just that divided by the interest rate. What we call that in the real estate biz that your textbook doesn't call it is the cap rate, the capitalization rate, which you guys saw in finance, Foundation for Finance, right? The capitalization rate, does that ring a bell?
No.
Brady says yes, everybody else says no. So the capitalization rate, it's basically that exact formula, except it's saying that the price today, if the price of the land is $12,000, should I buy it So if the price of the land is $12,000, so what you can do is figure out the capitalization rate. What is my rate of return? So the cap rate of return. How would I do that with this problem? I've got some land that's offered for sale at $12,000 and it brings in $1,000 per year. How would I figure out the rate of return on the land?
So you have PV of
Well, talk to me in terms of the problem here. So I've got a 12. I can give up $12,000 today. Is everybody with me? I can buy the land today for $12,000. I have that on the table from the seller, and I'm expecting it to pay out $1,000 a year for forever. What's my rate of return? What is it? If I flip that over, 1,000 divided by 12,000. Right? So I'm getting $1,000 return is my income. That's my income off the property divided by the purchase price. So this is the flow, the cash flow or whatever, calling it that way, or the income, divided by the purchase price equals the interest rate. Now, if you study this thing real carefully, it's like, oh, I get it. This is the R. That's the PV. And this is the interest rate. So if we solve for PV, I bring this sucker over to this side. Present value equals rate over interest rate. So it's the value of a perpetuity, if you remember that. So how do I figure out the value of something that's going to pay me $1,000 for forever? It's called a perpetuity. There was bond instruments like that before. What's that worth? That's how you calculate the value. Okay, so that was kind of a long way of coming around to this is a cap rate. The thing I didn't like about the textbook is he just says the present, like that's the present value formula. That's not the present value formula. What I gave you, what we just walked through, is the present value formula. But that is a special case of the present value formula where the payment is going to go for infinity. Then the present value formula breaks down to that. All right. So I'll probably beat that dead horse. Any questions? All right, got a couple minutes left here. Let me just tie this together here with this piece, and then we'll do that. So this leftover principle is how much are we willing to pay for the land? If the land is, what was our other state? Texas, then the average cost of farming the land is higher, right? Because it's not as productive. If we look at the cost per bushel of corn, if the land's not as productive, the average cost per bushel is going to be higher. So the profit margin is going to be less versus the fertile ground. And so that's going to play a role on what those profits are. Now we go back to our present value calculation and we think about how the land values are going to change. Okay, well, I don't want to go there yet today, so yeah. Looks like a good spot.